Okay, here we are on page 174, number 10. 20% of the vehicles are trucks, 16% are buses, the remainder are cars. We've got a sample of 11, and probability that fewer than 3 are buses. All right, so let's spell this out. We got 20% are trucks, 16% are buses, and that means that 64% have to be cars. All right, so we got 11 trials here, and this is a binomial situation because it's either a bus or a not. It's either a bus or a not. So I know the probability of it being a bus, it's 0.16. I know the number of trials there were, 11, and so I can fill in this information. Now the problem is, if I multiply 11 times 0.16, it's going to be less than 5, so I cannot approximate it with normal distribution. So I go back to my formula. 11 combination 0, and then times p to the 0, and then q to the 11th. And then I go through and I got to do it, well, what if there's 1 car? And then what if there's 2 cars? So I find the probability of all these cases. Now the thing is, remember, it's less than 3, so it's not going to include 3. So 0, 1, or 2, that's all I got to do. And if I multiply all this out, I get all these long, crazy numbers. And I jot them down. And then I've got to add all up to find the probability of it being less than 3 cars. Now, you don't really need to add up all those numbers. We need to go 3-something figures. So if you add up the first 5, you should be okay. If I do, I'm going to get this. And if I do all of them, I'm going to get this other big long number. At any rate, 3-something figures is going to be 0.748. All right, good. Let's go on to part 2. In part 2, we got 125 vehicles, and they want us to use suitable approximation. They're begging us to do a normal distribution. And now that there's more trials, it will work out. So let's go ahead and do this. We got 125 trials, and the probability now of it being a car, if you recall, was 0.64. They switched on us. And if I multiply this, I'm going to get numbers bigger than 5. 125 times 0.64 and 125 times 0.36, they're both going to be bigger than 5. And so now I know that I can use it. So I'm going to go ahead and write this as a normal distribution. V is normal distribution. And now I take the number of trials times probability of success, and that's going to give me my expected value, or my mean. And when I do that, I'm going to find out that it's 80. So I fill that in. And then when I take the 80 times probability of failure, that's going to give me my variance. And that is going to be 28.8. All right, so now I just proceed like a regular problem. I'm trying to find the probability that V is greater than 73. All right, now keep in mind, because of this approximation, we got to make it a continuity adjustment. All right, so it does not include the number 3. It's more than 73. So what we've got to do is we've got to pick a number that's half bigger. It's going to be 73.5. And that's going to take away that minus 80 over the square root of 28.8. And then all I got to do is figure out what that number is. Probability of Z is greater than negative 1.211. Well, keep in mind, my table doesn't really deal with negatives. It's over here on this side. That's going to give me everything over to the right. But if I take the number that's symmetric with it, positive 1.21, that's going to give everything over to the left. The areas should be the same size. So I go ahead and do that. 1.211. And I need a table. So I pull my table up and I go to 1.21. That's my number. Now I go over here and I add another digit, 1. I put a 0.0002 on the end. And that's going to give me a probability of 0.8871. It rounds to 0.887. And that's all there is for that. All right, thanks for watching.